In this paper slide video, we will be explaining L'Hopital's rule.
L'Hopital's rule states that if f and g are differentiable and the limit as x approaches a of f of x over g of x is 0 over 0 or infinity over infinity, then the limit as x approaches a of f of x over g of x is equal to the limit as x approaches a of the derivative of f of x over the derivative of g of x. In other words, if the limit of a function is 0 over 0 or infinity over infinity, you can simply take the derivative of the top and bottom separately and find its limit to determine the limit of the original function. Let's try an example.
Say you have the limit as x approaches 1 of ln of x over x minus 1. When you plug in 1 for x, you get 0 over 0, so you can then use L'Hopital's rule. So you take the derivative of the top, which is 1 over x, and the derivative of the bottom, which is 1, and you plug in 1 for x, which this gives you 1. Therefore, this example gives you the limit of x as approaches 1 of ln of x over x minus 1 equal to 1.
Sometimes the limit of the function will not equal 0 over 0 or infinity over infinity. These are 5 indeterminate forms that don't look like it. If your function equals one of these 5 incognito indeterminate forms, you can manipulate the function so that its limit equals 0 over 0 or infinity over infinity. You can then use L'Hopital's rule.
Say you have 0 over 0 or infinity over infinity. Just use L'Hopital's rule directly. If you have 0 times infinity, rewrite as division, then use L'Hopital. If you have infinity minus infinity, find a common denominator, then use L'Hopital. If you have 1 to the infinity, 0 to the 0, or infinity to the 0, use the natural log to pull out the exponent and then use L'Hopital.
Example 1. The limit as x approaches infinity of e of x over x squared. The first question you should ask yourself is if you can use L'Hopital's rule. Well, the limit as x approaches infinity of e of x is infinity. The limit as x approaches infinity of x cubed is also infinity. So yes, you can use L'Hopital's rule. So you take the derivative of the top, which is e of x, and the derivative of the bottom, which is just 2x, and you plug in infinity to get infinity over infinity. You can then use L'Hopital's rule again. Then you have limit as x approaches infinity of e of x, and the derivative of 2x, which is 2. You plug in infinity to get infinity over 2, which is infinity. Therefore, your final answer is the limit as x approaches infinity of e of x over x squared is infinity.
Example 2. The limit as x approaches infinity of x times e to the negative x. When you plug in infinity for x, you get infinity times 0. This is an indeterminate form. If you refer back to your previous slide, you will see that when you get 0 times infinity, rewrite the function as a division, then use L'Hopital. So you rewrite the function as limit as x approaches infinity of x over e to the x. When you plug in infinity for x, you get infinity over infinity, and then you can use L'Hopital. So the derivative of the top is 1, and the derivative of the bottom is e to the x. Plug in infinity for x, and you get 1 over infinity, which is equal to 0. Therefore, the limit as x approaches infinity of x times e to the negative x is 0.
Example 3. You have the limit as x approaches infinity of 1 plus x to the 1 over x. When you plug in infinity, you get infinity times 0. If you refer to the previous slide, you get infinity to the 0, and you use natural log to pull the exponent out, and then use L'Hopital. So let f of x equal 1 plus x to the 1 over x. Then you get the limit as x approaches infinity of ln of f of x equal to the limit as x approaches infinity of the natural log of 1 plus x to the 1 over x. But since you put the natural log in, you have to bring the exponent down, and you get natural log of 1 plus x all over x. You plug in the infinity to get infinity over infinity, which then you can use L'Hopital. So you take the derivative of the top, which is 1 over 1 plus x, and the derivative of the bottom, which is just 1. You simplify to get 1 over 1 plus x. You plug in infinity to get just 0. But the limit as x approaches infinity of the natural log of f of x is 0. To undo the natural log, you have to use e. Therefore, the limit as x approaches infinity of f of x is equal to e to the 0, or just 1. So your final answer is the limit as x approaches infinity of 1 plus x to the 1 over x is 1.
The end!